Welcome to our final lesson in this chapter where we are discussing advanced REST API concerns. In this lesson, I'm going to talk about building asynchronous REST API. Now, to make sure we are on the same page when it comes to asynchronous, I included a little diagram that will help me explain this concept. When I say asynchronous APIs, I mean that the processing of a single API request is detached from an HTTP request. Let's illustrate this with an example. Let's say we are sending a very large dataset to the post endpoint for creating the entries. The server could respond with a 202 accepted response without actually processing these records and persisting them in the database. Instead, it can return a URI which represents a resource, let's call it a job resource or a status resource, where the client can poll to check for the status of this processing. This is also the simplest implementation of this, just polling on the client side and sending a GET request to the status endpoint, where the response typically includes the status of the processing, while the API is doing the work in the background. And let's say once the status is complete, then it's going to include a list of URIs where you can access these entries. After that, the client can send a GET request to the respective URI for this entry and get back the actual data. An alternative approach to using polling on the client side is using some sort of mechanism that allows the server to notify the client that the work is complete. This could be implemented with something like server-sent events or WebSockets, and SignalR is an excellent candidate for implementing this functionality. Another good example of implementing async processing on your REST API could be processing file uploads, where the upload process itself completes fairly quickly, but it's the background processing of the file that takes up a considerable amount of time. Instead of blocking on the client side until all this processing is complete, you can simply return a resource URI that represents some sort of background job, and the client can use this information to poll for the status of the job. And this is something that I'm going to implement as part of this chapter. So let's jump into the code and let me show you how all of this works. Below this video, you will find the latest state of the source code, and I recommend that you go ahead and download it because you will need it if you want to follow along with this chapter. The implementation I'm going to show you is pretty complex, and writing all of this from scratch wouldn't be a good use of our time. So I went ahead and implemented this functionality behind the scenes, and I'm going to walk you through the most important highlights. Now, if you open up the controllers folder, you will see a new controller, the entry imports controller. So in this case, I'm modeling my background work as an additional resource on my API. The route is entries/imports. It has the standard authorize attribute, the API controller, the API version, which media types it produces, and then inside of our actual endpoints, this is the functionality that we are implementing. The first endpoint is creating an import job. This accepts a create entry import job DTO, which is just a file. Now, inside of ASP.NET Core, you can use an iForm file to accept a file that's being sent using a form data request. I'm validating this file using a respective validator, which is going to check that the file exists, that it's not larger than some maximum length that we set, and that the file extension type is a CSV file, which is the only one that we support. Inside of the endpoint, what I'm going to do is load the file into memory and then use that to create an entry import job. This will uniquely identify this background processing, and this is how we'll be able to poll for the job status. This is going to contain the user identifier so that we can track the imports for a specific user. The status is an enum, and the initial value is entry import status pending. I'll also include the file name, and I'll store the entire memory stream as an array of bytes just for simplicity's sake. Alternatively, we could store this to some object storage like Azure Blob Storage or the AWS S3 service. Then we're going to add this to our database and persist these changes, and the next step is actually kicking off the background work. So we're going to schedule a new instance of the process entry import job, and I'm passing in the job ID as the data for this background worker. I'll schedule this using Quartz and the iScheduler interface, and I'm going to say that the background processing should start right away. Then I'll create my DTO, include the hypermedia links if the accept header says that we should, and I'm going to return a 201 created response. The location header is going to point to the get import job endpoint, and I'll specify the job ID as the route argument, and I will also include the entire DTO in the response. Then we have a get endpoint that will allow me to fetch all the import jobs for this current user. Now this will support pagination, and it's also going to return hypermedia links. And then we have the get import job endpoint that is just going to return the data for one import job based on the identifier. Now what about the background worker? Well, let me go back to where we are scheduling it, and then let's go into the definition. What we're going to do here is first fetch the import job ID. We'll try to fetch the specific entry import job from the database, and then we can use it to load the file into memory. I installed an additional NuGet package, the CSV helper NuGet package, that's going to allow me to parse the CSV file into a collection of CSV entry records. Now, if I go into this type, it only has the habit identifier, the date, and the notes for the particular entry. So I'm envisioning this as a user coming over to the dev habit application, and they have some data in a different habit tracker that they want to export and then import into the dev habit system. This functionality is going to allow them to do this. What we're going to do is process all of the records from this file and create the respective entries based on the values inside. I also added a new entry source, the file import, and we'll process all of the data from the CSV file and create the respective entries. And in the end, we're going to update the import job status to either be completed or failed if we run into some exception where we can't recover. If you open up the jobs folder, you will also see a job for cleaning up any entry import jobs that were left hanging, and here you can decide what kind of retention policy you want to implement. For example, I'm removing any successful jobs that are older than 7 days, I'm deleting failed jobs after 30 days, and I'm also deleting any stuck jobs if they have been processing for more than 2 hours. Of course, you're welcome to customize this however you think is suitable. The cleanup job is scheduled to run once per day. I configured this inside of the add background jobs method, which you can see here, and it's scheduled to run at 3 a.m. UTC time once per day. I used a cron schedule to configure this. We still have our GitHub job that runs on a recurring schedule, and this is something that we added in the previous lessons. Now, when it comes to the entity representing the entry import job, here's what it looks like. Nothing too out of the ordinary from what we've already seen. Something that might be new is storing an array of bytes in the database. It's something that databases support. I also have a list of strings representing any validation errors that I run into when processing the import job, and Postgres natively supports this without any additional configuration. If you were using something like SQL Server, then you will need to serialize this to and from JSON, and you could define a simple value conversion with EF Core. Now, if we go ahead and start the application, and I jump into Postman, where I have a post request for triggering the import entries job, all I need to do is send a CSV file containing the required data. Now, I already created this file ahead of time, and you can download a sample file right under this video. The only thing that you will need to adjust is the habit identifier, which may be different in your system. So I can go ahead and send this request, and it's going to kick off the background processing, and I'll get back a representation of my background job. It's going to contain the file name, how many records were processed, and the status of the job, and it's also going to include the specific URI in the location header of the response. Now let me take the identifier of this job, and I'm going to paste it in the GET request, and when I send this request, you can see the results of this processing. The status 2 means the job successfully completed. We also have how many records were processed. You can see we're counting the total number of records, the number of processed records, and the number of successfully processed records. In this case, the number of failed records is 0, and we don't have any errors. So this is a pretty straightforward implementation of asynchronous processing with a REST API. Now, I also integrated this into the client application. So if I go into the client application and navigate to my habits, I created a custom habit that I'm using only for imports. This is the one that's specified in the CSV file I'm using for the import. Now, if I go into my entries, now there's a new button here called Import Entries, and if I click this button, I can see any previous imports that I've ran. You can see I performed a couple to test this out, and I have a drop down here where I can add the file that I want to upload. Now, it only supports CSV files, and we clearly communicate this. If I go ahead and grab the file that I want to upload, and I'll open up the network tab so that we can track what is going on. And I just need to drop the file into this zone, and you will see that it's going to send a request to our post endpoint, which is going to start the import, and it's immediately going to refresh the list of records. And you can see that our file is already processing. An improvement here could be checking if we have any import jobs that are in the status of processing, and if they are, we can implement polling where we fetch all of the entries again, or just the specific one to see if the status will update. Now I'm going to go back to the entries and just visit back the import entry screen again, and you will see that our latest update has successfully completed and our entries are properly imported into the application. And with this, I'm going to wrap up the chapter about the advanced REST API concerns. I highly encourage you to grab the source code that's available right under this video and test out the implementation for async processing inside of our REST API. A nice improvement that you could make if you want to practice this is integrating SignalR for notifying clients when the job processing is complete. This will also improve performance because the clients won't have to poll our REST API to see if the job processing status has changed. Our next big topic when it comes to building REST APIs is ensuring that they actually work as expected. So in the next chapter, we are going to be talking about testing REST APIs.